Hello, developers, architects, and today I'm here to tell you that you are writing too much application code. Yes, that might sound weird as you're a developer and writing code. It's kind of your job, but you're writing too much of it. If you're building serverless applications, there's a way you can reduce the amount of code you write. Now, why might you want to do that? I hear you ask. Well, any code that you write and run in production gives you some overhead. You need to manage SDK versions, keep code up to date, all for what might be some trivial things, especially when you're building serverless applications and you can shift some of that responsibility onto AWS. So in this video today, I'm going to show you how you can write less application code. You're still going to write code, of course. You're just going to shift that code around a little bit. You're going to use the code to define your resources, but have absolutely zero application code running in production. Less overhead, less maintenance. Let AWS worry about everything and you can focus on writing code that adds value. If you like this channel, I would really appreciate a like and a subscribe. So if you hit that like button, hit that subscribe button, ding that notification bell. It would mean so much to me. A quick side note before we get into that, I have just launched a Getting Started with Software Architecture course on the Dome Train platform run by the brilliant Nick Chapsis. This covers the fundamentals of software architecture. Agnostic of cloud or technology stack, it provides everything you need to know to get started in the world of software architecture, from gathering business requirements right down to application-specific design patterns. So you're a .NET developer and you're building things with AWS Lambda. You're building serverless applications, and this might be something that you're relatively familiar with. Even if you're not building with Lambda, this kind of API endpoint will probably be very familiar for you. So this is using the Lambda annotations framework, my favorite way of building Lambda functions now, and it just abstracts away a lot of the underlying boilerplate code. And what you've got here is a API endpoint. Imagine this is part of a bigger CRUD-based API. I've simplified this right down for the purposes of this video. And fundamentally, all this API endpoint is doing is writing some data to a database and then publishing an event to say that something has changed. In this case, it's some generic order stuff. And of course, this is very simple application code. And you might think, why do I want to get rid of this? Well, any code that you write has the potential to go wrong, especially if it's code that I'm writing. There's a lot of potential for it to go wrong there. And this means you need to keep these packages up to date. If a new version of the AWS SDK comes out, you need to update it. That is something that you need to take on. For every single piece of code that you write, you need to maintain that piece of code. So for simple cases like this, why would you not want to shift more responsibility onto AWS? Why would you want to maintain this code and write this code for, frankly, what isn't that interesting work? All you're doing is saving stuff to a database, publishing an event to an event bus. Like, you're a developer, you want to be doing more exciting things than this. So let's have a look how you can start to move away from this simple code and shift all of this responsibility onto AWS. And we're going to do that using the AWS CDK. So although I said you're writing less code, what I mean is less application code. You're still going to have to write some .NET code, of course. And let's go and have a look at a CDK project. So I've initialized a brand new CDK project using CDK init app --language C#. Something should be appearing over here somewhere to show you that. And I've got this new CDK project. And what I'm going to do is show how you can start to reduce the amount of application code that you need to write. So the first thing I'm going to initialize is a new DynamoDB table and an event bus. In our application code, we've got a table to store the data in and then an event bus to publish the events to. And then I'm going to use an AWS service called Event Bridge Pipes. Pipes allow you to create point-to-point integrations between two different things. That might be a queue to a step function. That might be a stream to a event bus, which is exactly what we're going to use here. So you see on my DynamoDB table, I've actually enabled DynamoDB streams. What this means is that every single change that happens in my table will be streamed out and I can then read data from that stream. So I'm going to create a new IAM role for my pipe to use. And then I'm going to allow that role to read from my stream and put events to my event bus. And then I configure my pipe. And my pipe is pretty simple to configure, really. All I'm doing is setting the name of my pipe and the role that I want the pipe to assume, which is the role I've just created further up. The source of my pipe is my DynamoDB table. I want to start from the latest point in that table and take batches of 1. And then I want to target my event bus. And I'm going to set some target parameters, specifically that the type is order updated. It's coming from my orders system. And then, really interestingly, I can specify what's called an input template. And an input template allows you to transform the data that comes into the pipe as it gets sent to the target. Because when you think about the data that comes out of DynamoDB streams, it's quite complicated. If you just flick over to the AWS console for a second and come to the Amazon EventBridge Pipes console, you can configure a target in here if you create a new pipe. And if you just look at the sample event for a DynamoDB stream event, it's actually not that simple. If you were to publish this straight to an event bus, that would really, really confuse people reading your event. And you can use input transformers to transform that DynamoDB stream data into something that actually makes sense. And I've done that in a JSON file. If you have a look within the application code, there is this input transformer, and this input transformer allows you to transform the data from the source to the target. So I'm creating a new JSON object. I've got an order ID property, a value property, and an address property. And then I'm reading that data from the data that's actually flowing through my pipe. If you look back at the sample event from DynamoDB, you see you've got this DynamoDB property, then you've got the new image, and if this was a modification or a delete, you'd also have a copy of the old image as well. And then you can actually, in the console, click various fields here to actually build out the transformer that you want. So this allows you to now take data from a stream, publish it to an event bus, transform it into a format that you want with absolutely zero application code. Taking data from that stream to that event bus is now AWS's responsibility, not yours. So if you come back to your Lambda function now, you can go ahead and just delete that event bus completely. Let's get rid of all references to our event bus because they are no longer needed. All you need to do is store the data in the table. Pipes will handle the rest. Let's take this one step further. Let's take this so far that we can come into here and delete that entire Lambda project completely. You can do that using API Gateway and Amazon Step Functions. Step Functions integrates directly with API Gateway, which means you can trigger a step function from an API call. And let's have a look how you can build that out. In this same CDK project, you've got this front-end API service. This is where you're actually going to define the step function. And within this workflow, I've got 3 steps. The first step is to generate a unique identifier, and that uses the states.uuid intrinsic function. I've then got a second step to store that data in my DynamoDB table. I'm using the Dynamo put item, the native service integration that allows step functions to integrate directly with DynamoDB. I'm doing that by setting my order value, my order address properties to the actual values that are within my step function state. So when API Gateway invokes step functions, it passes in the entire HTTP payload. That's why I'm using $.payload.body, body of the request, and the order value, and then $.payload.body.order address on the end there. So that has now generated me an order number, stored the data in DynamoDB, and then finally, I'm just going to do some formatting just to make sure that the response that gets returned by my step function is actually something that is legible from a HTTP perspective. So I'm just building a HTTP response there. Then finally, I'm allowing my step function to read and write data from my DynamoDB table, and then I'm creating my actual API. One of the beautiful things about the AWS CDK is it has these level 2 constructs. So I can simply create a new step functions REST API, pass in my step function, and the CDK will handle setting up all of that stuff in the back end to make sure that all that integration works correctly. One final thing to call out, if you go and have a look at this default state machine, for this to work, your step function needs to be of type express workflow. So you'll notice when I create my step function, I'm using state machine type.express. This has to be the case for the integration to work between API gateway and step functions, providing you want to get the response from your function back to API gateway. And that's it. Now you've got a step function that is going to write the data to your database, and you've got the pipe that we created earlier to actually take that data from the DynamoDB table to your event bus. All of this is now working without a single line of application code. Almost all of the operational responsibility for this API is now on AWS. And that allows you, developers out there, to focus on writing more valuable code. Okay, so one final thing I'm going to do before you see this in action is I'm actually going to create a rule on the event bus you've just created to allow you to see that this is working. And there's a really simple way you can do that. If I come to the Amazon EventBridge console, come to the buses and the rules tab, and you want to create a new rule. Let's call this log order events, leave the description empty, and you want to make sure you use the custom event bus that you've just created. In terms of the event that you want to match, if you scroll right down to the bottom here where you can enter the event pattern, open that edit up, and we just want to match where the source of the event is ordered. If you come back to the actual pipe that you created, you see that the source of the event that you're publishing to event bus is orders. So let's match up all events that are coming from the orders system, and you want to target CloudWatch log groups. This just allows you to log everything that's coming through, and let's call that order updated logs. Hit next, create the rule. And now you've got a rule here against your event bus. So when you test this, you can actually see that everything is working. So let's open up Postman now, and you will have the API endpoint for the API that you've created, and you can make a request to this API. Remember, we need two properties on our API call: order value and order address. So you've got them there, and I'm going to hit that API endpoint now with some data, and that will respond. And you see I've got my order ID back that's been generated by my workflow. And you see actually my API response time there is 371 milliseconds. Hit this a few more times, and you will get an incredibly consistent API response time here, no matter how often you hit this. This is one of the other benefits of building in this way, is that you don't have to think about things like Lambda cold starts and whether Lambda is scaling, because this is all happening managed by AWS. So we've hit that enough times now. Let's come back to the AWS console, and you'll go off to the CloudWatch console, and there will be a set of logs in here for AWS/events/order updated logs. There we are. And you see we've got a whole bunch of logs coming through this log stream. Open up one of them. Let's have a look at the data, and you see the actual data that's been published there is exactly as we expect. And actually, if I've picked the right one there, that should be the last event that was published, 1CF1, and we've got the exact same event that has been published through there. This is now an API that's running, it's storing data in a database, publishing an event to Amazon EventBridge. You're transforming that data using a custom event type, all without a single line of application code. You as a developer can now be completely focused on writing code that actually adds value. None of this CRUD-based APIs that, frankly, none of us find very interesting. Now you can do super interesting things. Let AWS worry about these simple CRUD-based APIs. That's all for this video. Remember, if you're building serverless, always think, how can I write less application code? And you can still write some code, providing you're using the AWS CDK. You've got all that lovely C# .NET goodness. You just don't have to operate that in production. Thanks for watching. If you've enjoyed this video, please like and please subscribe, and I will see you all in the next video. Keep on building.